We are a curious species. Since our earliest days we have looked up at the night sky. We saw a tapestry of tiny lights scattered across an infinite black canvas. We wondered what they were. We told stories about them. Gods and monsters, heroes, distant heavens. This curiosity is written into our very being. It is a fundamental part of what makes us human. We have an endless hunger to know what lies beyond our small blue world. It is a drive that has pushed us to climb the highest mountains and to cross the widest oceans. Now it is pushing us to the very edge of the universe. This need drove us to build tools beyond our eyes. We build bigger eyes that see the invisible. We point them to the heavens, hoping to catch a glimpse. Each new tool takes us one step further, from simple spyglasses to giant mountaintop observatories. But even these were not enough. The universe held its deepest secrets just out of reach, hidden by time and dust. We needed something more, revolutionary, so we dared to dream bigger. We imagined a magnificent eye, a golden mirror folded like origami. We would send it far from home, 1,000,000 miles from Earth, a silent sentinel floating in the cold, dark void of space. Its mission? Look back. Look back so far it could see the very beginning of everything. The first stars igniting the cosmic darkness, a time we've only imagined. We called it the James Webb Space Telescope. Now that dream is real. Unlike its famous predecessor, the Hubble Space Telescope, which sees primarily invisible light, Webb sees in infrared. Infrared is a special kind of light, invisible to our eyes. Think of it as a form of heat. This ability is Webb's superpower. It allows two extraordinary things: see through thick clouds of cosmic dust hiding newborn stars and planets, see the ancient light from the farthest reaches of the universe. To see this faint ancient heat, Webb must be incredibly cold. Any warmth from the telescope would blind it, like photographing a candle in a bonfire. So it was sent 1,000,000 miles from Earth to a special point in space. There it hides behind a massive sun shield. One side of the shield is scorching from the sun. The other side, with mirrors and instruments, drops to about 370 F. This feat of engineering lets Webb's primary mirror do its job. Imagine looking at a star that is 10 light-years away. The light you see tonight left that star 10 years ago. You are not seeing the star as it is now. You are seeing it as it was in the past. This is the fundamental principle of cosmic observation. The farther away we look, the further back in time we see. The universe is about 13.8 billion years old. So, if we can look far enough, we can see light that has been traveling for nearly 13.8 billion years. We can see the universe not as it is today but as it was when it was just an infant. This is Webb's ultimate purpose. Before Webb, our view of this early era was blurry. It was like trying to read a book from across a hazy room. We had theories. We had models. We believed we had a good idea of how things began. The story went something like this. After the Big Bang, the universe was a dark, simple place. It took hundreds of millions of years for gravity to slowly pull together the primordial gas. This gas would eventually form the first small galaxies. This gas would form somewhat messy galaxies. These early structures would then collide and merge over billions of years, gradually building large galaxies, majestic spiral galaxies, elliptical galaxies we see today. It was a story of slow, orderly, cosmic evolution. Webb was built to confirm this story. Scientists expected to point its golden mirror toward the deepest parts of the sky and see faint proto-galaxies. The first disturbing discovery came from Webb's earliest deep-field images. These were observations of a patch of sky that looks empty to the naked eye. Webb stared at that patch for hours, collecting ancient light from the edge of the observable universe. When the images were processed, scientists were stunned. They were looking at galaxies from just 500 to 700 million years after the Big Bang. It's like finding a photograph of a newborn baby. But these were not the tiny, underdeveloped infant galaxies our models predicted. They were shockingly massive. They were surprisingly mature. Imagine planting a forest. You plant tiny seeds. You expect small saplings. Instead you find fully grown, towering oak trees. Astronomers felt that shock. These early galaxies were enormous. Some had as many stars as the Milky Way does today. According to cosmology, this should be impossible. There simply was not enough time. The process was thought to take billions of years, gathering gas-forming stars growing into a massive structured galaxy, not a few hundred million. This finding hits the heart of galaxy formation models. It suggests the process was not slow and gradual, violent, rapid, incredibly efficient. The universe seemed in a hurry to build its largest structures, which raises new questions. As Webb continued its survey of the cosmos, it turned its golden eye not just to distant galaxies but also to the stars within them. And here, it found another unsettling puzzle. Deep within a swirling nebula, a place where stars are born, Webb detected a star that defies our current understanding of stellar evolution. This star, provisionally named the Improbable, is a true monster. It's estimated to be over 300 times the mass of our own sun. According to the established theories of star formation, a star of this size simply should not be able to exist. It's just too big, too bright, and way too unstable. Our models of how stars form are built on a delicate balance. A star is a constant battle between two opposing forces, the inward pull of gravity which tries to crush the star, and the outward push of radiation pressure from the nuclear fusion in its core. For a star to be stable, these forces really have to be in equilibrium. However, as a star gets more and more massive, the radiation pressure it generates becomes overwhelmingly powerful. The theory, known as the Eddington limit, predicted that any star-forming cloud that grew beyond about 150 times the mass of our sun would just blast itself apart before it could fully form. The Improbable laughs in the face of this limit. At over 300 solar masses, its radiation pressure should be so intense that it would have blown away all the surrounding gas and dust, effectively starving itself and preventing any further growth. Perhaps the most tantalizing discovery from Webb comes from much closer to home. And honestly, it's disturbing. It comes from an exoplanet. A world orbiting a distant star. For years we've found thousands of these planets. But Webb is the first telescope powerful enough to study their atmospheres in detail. Webb does this by watching the planet pass in front of its star. As the starlight filters through the planet's atmosphere, certain wavelengths get absorbed by molecules. Webb reads this barcode of absorbed light and tells us what the alien air is made of. It's in one of these barcodes that Webb found something truly strange. The target was an exoplanet named K218b. K218b is a sub-Neptune world about 8 times the mass of Earth. It orbits within its star's habitable zone, the habitable zone, where temperatures could allow liquid water on the surface. Previous observations hinted K218b might be a Hycean world, a planet with a deep liquid water ocean, beneath a hydrogen-rich atmosphere. Webb pointed its instruments at this world hoping to confirm water vapor. It found water, but it also found something else. A molecule that, on Earth, is produced almost exclusively by living organisms. The molecule detected, dimethyl sulfide or DMS. On Earth, DMS is primarily produced by phytoplankton. In marine environments, it's part of what gives the sea its characteristic smell. These discoveries are not just interesting footnotes to add to our astronomy books. They're seismic shocks, forcing a complete reevaluation of entire fields of study. The neat chapters on galaxy formation, stellar evolution, and the conditions for life are being torn up and rewritten in real time. The universe that Webb is revealing is wilder, faster, and more mysterious than the one we thought we knew. The age of comfortable theories and tidy models may be over. We've entered an age of profound cosmic uncertainty, and it's both thrilling and unsettling. The impossible galaxies at the dawn of time are a perfect example. They challenge the standard model of cosmology itself. This model, which includes dark matter and dark energy, has been incredibly successful at explaining the universe on large scales. But it can't easily account for such rapid galaxy formation. Some scientists are now exploring radical alternatives. Could dark matter behave differently than we thought? Could the force of gravity itself be modified on cosmic scales? Webb's data is forcing us to confront the possibility that our most fundamental theories about the universe are incomplete. The textbooks are not just being rewritten, they're being prepared for a completely new volume. For all the incredible things Webb has seen, it's what we haven't seen that can be just as disturbing. We've pointed our greatest instrument at the sky, and found a universe that seems to be teeming with the potential for life. So where are they? Why do we see no signs of their technology, no galactic engineering projects, no messages echoing across the interstellar void? The silence is unsettling. It leaves us with a few stark and disturbing possibilities. Perhaps life is incredibly common, but intelligent life is exceedingly rare. Or perhaps civilizations inevitably destroy themselves before they can ever reach a galactic stage. Another possibility is even more chilling. Perhaps they are out there, but they're deliberately silent. In a dark forest, you don't shout. You stay quiet for fear of attracting predators. The James Webb Space Telescope has given us an unprecedented view of the cosmos, but it's also highlighted the profound and unnerving silence that surrounds our tiny, noisy world. We built the James Webb Space Telescope to find answers. Instead, we've found chaos. We found unsettling truths that shake the very foundations of our knowledge, galaxies that are too big, stars that are too massive, whispers of life from a world we can never touch. The James Webb Space Telescope is still out there, a million miles away, silently gathering light. It will undoubtedly uncover even more mysteries, more anomalies, more things that simply should not be. And so, we're left staring into the darkness once more, just as our ancestors did. But now, our view is clearer, the darkness is filled with more wonder and more mystery than ever before. It leaves us with the one question that has haunted us from the very beginning, a question that now feels more urgent and more profound than ever. What else is out there?